All right, now in this slide, what we are seeing is the following. So you saw in the linear motion case, velocity was a vector. Well, angular velocity is also a vector. For a vector, you need two things. Vectors have two things, magnitude and direction. And so for angular velocity, we need to define the direction of the angular velocity. So here's how you figure out the direction of the angular velocity. So there is the axis of rotation of this object that's rotating. And as it rotates this way, the way you figure out the direction of the velocity is you take your right hand, your fingers point in the direction of rotation. Okay, so your fingers strap in the direction of rotation and your thumb points in the direction of the velocity. So the faster this thing is spinning, the greater the magnitude of the velocity is indicated by the length of the arrow and length of the vector. So the magnitude is given, of course, by the length of the vector, and the direction is figured out using your right hand. So if the object is rotating in that direction, the velocity is pointing in this direction. See, there's your thumb. So that's how you figure out the direction of the velocity vector. All right, so here's here's this object. There's the axis of rotation. It's rotating like that. And you see, this is the linear speed. This is the linear speed of the object. This guy is going in a circle. Every point is going in a circle. The closer you are to the axis, the smaller the circle you're going in. And the further away you are, the bigger the circle you're going in. And your linear speed has to be greater. The angular speed is the same for everyone. And obviously points on the axis are not moving. So what is angular acceleration? Now, this is the angular velocity. If this changes, if the angular velocity changes, you have angular acceleration. Okay. So angular acceleration denoted by alpha is change in angular velocity divided by the time over which that change happened. So if your angular velocity does not change, then angular acceleration is 0. So if this does not change, acceleration is 0. And again, alpha is d omega by dt. So angular acceleration is time rate of change of angular velocity. Okay. So let me make up a motion. So let's say, so imagine this object rotating. Okay. And it's rotating about that axis. Okay, did you guys have a question? Something popped up on my screen. Does anybody have a question? Okay, so again, going back to that. So here's an example. Let's say its angular position is given by 5t plus 3. Angular velocity will be 5. Angular velocity is d theta by dt, which is equal to 5. And angular acceleration is d omega by dt, which is 0. Okay, so the reason I did this example is, so you saw that if the angular position is a linear function of time, angular acceleration is 0. That is, the velocity is, angular velocity is constant. If the angular velocity is constant, you don't have acceleration. Okay, so again, coming back to this slide. So angular acceleration is rate of change of angular velocity. Okay, so what this slide shows you is the following. Okay, so remember, for linear motion, if your velocity was increasing, this is initial velocity, final velocity, then your acceleration was pointing in the same direction. And if your velocity was decreasing, then the acceleration was pointing in the opposite direction. So now we'll do the parallel of that for angular motion. So let's say here's an object that is rotating. And if it's rotating like this, that's the direction of the angular velocity. And if it's rotating like this, that's the direction of the angular velocity. Now, if the object is speeding up, that means if the rotational rate is speeding up, then the alpha points in the same direction. Angular acceleration points in the same direction. And if it's slowing down, so if the rate of rotation is slowing down, then omega points in that direction and alpha points in the opposite direction. Okay, so you have to try and understand that. Okay, and that's what is shown in the slides. So let me go to the slides. All right, so there's the object. There's the object that is rotating, and what is shown here is the angular velocity and angular acceleration are pointing in the same direction. That means that the rotational speed, the rotational rate is increasing. And in this case, the angular velocity is pointing in the opposite direction of the angular acceleration. So this object is spinning that way, but its rate of spin is slowing down, okay, because the acceleration is pointing in the opposite direction. Okay, so that's what we're saying. If angular speed is increasing, then angular acceleration points in the same direction as the velocity vector. Okay, so right now, this is a good point to pause, and I'll let you ask questions. I want to make sure you understand this.